So the law of technology as applied to agriculture or temperate cropping systems was coined by a Australian crop physiologist named Victor Sadras, and you can see his quote here when he talks about agricultural technology. This is more of a a social science observation, but it has important implications for cropping system management, and I wanted to run through them with you. So agricultural technology solves problems and it creates problems. And let's go through a couple of examples that explain what I mean. BT controls northern corn rootworm. This is an insect pest. We also saw it in lecture 1. But it can also be controlled, rootworm can, by corn-soybean rotations. In other words, any rotation that gets you out of continuous corn year after year. So this was actually a pretty common control practice, just rotating your fields out of corn every second year. Corn and soybean was a common one. But over time, some rootworm populations are adapting by favoring a prolonged egg diapause. In other words, when the adult rootworm lays eggs, that egg doesn't just overwinter for one winter, it'll overwinter for 2 or more winters before emerging, before that larva hatches. And so if you're in a corn and soybean rotation, corn, then soybean, then back to corn, then this kind of adaptation is bad news. In any case, the point here is that we have these technologies, BT corn or crop rotation, which is kind of a technology, and these solve problems, but they also introduce problems. So in summary, the two technologies that were adopted to solve this particular problem of insect pests, BT corn and crop rotation, those technologies have created new problems, or perhaps it's more accurate to say that these problems evolved in response to the proposed solutions, and therefore we need even newer solutions, more innovation. Another example of a technology that is solving problems and potentially creating new problems is the increasing use of fungicides in corn, or what you can call foliar fungicides. So this is a product that's sprayed onto corn at either VT or tasseling or silking, so around flowering in corn, and it protects that plant against fungal diseases. And fungicide use is increasing in the United States and Canadian corn production. There's a number of reasons you can speculate why. One would be increased fungal disease pressure, possibly due to climate change. For example, in August 2020, this past August, Ontario had its first confirmed case of tar spot. You can also think, maybe, company reps are now recommending fungicide use more often. Maybe there's a marketing push, or maybe livestock farmers are increasingly concerned with the quality of the feed that they're, feeding to their animals. So fungicide is solving a problem, right? A perceived problem by farmers and people in the agricultural sector. But there could be some long-term, unintended, perhaps unpredictable consequences of fungicide use. And so two possible ones I'm speculating here is that, the spraying of fungicides in corn might affect soil microbiology, right? You're spraying onto the plant, but, droplets can fall down onto the soil and perhaps affect the soil. And so we know, as an example, that some species of fungi are important for corn to acquire phosphorus. They're very important for phosphorus acquisition early in the season. And so maybe in the long run, there's going to be a negative effect on soil fungi that'll in turn affect corn productivity. We also don't know about the effect of fungicides on beneficial endophytes. And these are microbes that live in corn plants, kind of like our microbiome. It's the corn microbiome, and these are bacteria and fungi that they can provide positives to that corn plant, benefits as well as, or be neutral, but they're not like a disease. And we don't know about, we don't really know very much about the, what you could call the corn microbiome. And so we don't know if we're disrupting any important processes going on in that corn microbiome with the increasing use of fungicides. So these are just some examples that illustrate this point, that technologies will solve problems, but they can create new ones as well. In the early 1900s, I think I got this statistic in 1920, but don't quote me on it. Sometime in the early 1900s, about 25% of all cropped land in North America was dedicated to growing oats. Okay, that's just an astounding number, about 100 years ago. Just that much oats being grown. In Ontario, very true, lots of oats being grown, primarily for the timber trade. And it's not because oats were used specifically like to make timber, but because the timber trade used a lot of horses, and those horses ate oats. So yeah, huge demand from the timber industry for Ontario oats. But then this happened, right? The timber industry mechanized. Many other industries that previously used horses also mechanized. Combustion engine, trucks, tractors, heavy machinery, basically everything powered by fossil fuels. So we have mechanization. We have, horse populations plummeting. We just don't need that many horses. And then as a result, we have in Ontario a 500% decrease in oat production. And if that's measured either in terms of area or total tonnage produced, just 500% decrease, okay, since the 1950s. That is a story mirrored across the planet. Just oat production fell off a cliff starting in the 1950s due to the mechanization. So let's use Henry Ford as a stand-in or figurehead for this broader change in mechanization, tractors, trucks, cars. So when Henry Ford was inventing the Model T, do you think he went to farmers and he said, "Hey guys, is this all right with you that I'm doing this? This is going to put a lot of horses out of work, and you guys grow a lot of oats, and so I'm not sure who you're going to sell those oats to because there won't be many more horses around. Is that okay with you guys? Is that all right?" No, of course he didn't do that. That probably wasn't even on Henry Ford's mind. And so that just shows you that the unintended consequences of different technologies. So this next idea about the law of technology is that it is combinatorial. Okay, so individuals, people like you and me, can take ideas from our ideas, different people's ideas, technologies we come up with or other people's technologies, and we can combine them to form new ideas, new technologies. And that's a very powerful feature. And here's an example, an Ontario example. This is from a conversation I had with a student, actually, when we were talking about cover crops. And he farms, and this is what he was talking about, told me. So many farmers actually want to grow cover crops, but they're in a corn and soybean rotation. And so the challenge of incorporating cover crops into that rotation is that both corn and soybeans are harvested quite late in the season, and there's not enough time before a frost hits for that cover crop to actually grow and, cover the soil. And so the challenge is that corn and soybean are harvested too late, and so you can't really plant a cover crop in time. But what if you could sow that cover crop before harvest, let's say about 4 weeks before harvest? If you could manage to get into that standing crop of soybean, for example, and sow a cover crop, well, then your problem solves. But of course, the challenge is that it's a standing crop of soybean, and how are you going to actually seed a cover crop without destroying that soybean stand? Some farmers are now actually using helicopters to go into their standing corn or soybean, more often soybean crops, and seeding their cover crop, normally cereal rye, okay, just before leaf drop, just before R7. So this is several weeks before maturity and certainly several weeks before harvest. And so, the guy, we can say again, this is a gentleman, Sikorsky. This is a picture of him. He did not invent the helicopter, but let's say, there's one individual who invented the helicopter. It would probably be Sikorsky if you had to name one person. Sikorsky, when he was inventing the helicopter, didn't think, oh, this is going to be great for farmers to use to sow their cover crops into their soybeans at R7. No, he did not think that, right? A farmer took this technology and combined it with an idea he had. And this is apparently a very, very successful practice. That cover crop is establishing quite well when it's sown by a helicopter, and it's putting on a lot more biomass, covering the soil a lot more than if it was seeded after soybean harvest. You can actually look at some videos on YouTube showing this, how farmers are doing this. It's kind of cool.